Hey everybody, Bill Sky, the C and C++ guy, and what we're going to be talking about today are data structures, a specific data structure called a linked list. Now, you can do this in C, you can do it in C++, you can do it in Java, and if you take a look at my Java playlist, that video will be there relatively soon. We'll see. But we're going to do it we're going to just talk about what a linked list is, what a data structure called a linked list is, and then in future videos, we're going to actually code it. And we're going to go through every possible algorithm, deleting nodes, adding nodes, figuring out the length of a linked list. We're going to do the whole thing here on these videos. But let's just do an introduction to linked lists. What is a linked list? A linked list is a data structure much like a vector or an array, but it uses data and pointers to go from one node to the next. So let's first of all talk about what a node is in a linked list. So in a linked list, you have, and I'm going to use these boxes like this, you have a node. This is called a node. You can call it anything you want, but this is called a node, and it has two parts. It has the data. I'm not sure why that's so big, so let's go ahead and clean that up a little bit. So you've got data on the left side of the node, and then you've got a next pointer. And what the next pointer does is it points to the next node. Now, we're going to talk about why linked lists are so important, but if you have one node in a linked list, your next node will point to null, or in C++, null PTR. Okay? So, again, the next is a pointer to another node, not to the data, but to another node, and the data is inside of that node. Now, before we actually talk about adding nodes to the end, there's normally a pointer in your linked list implementation called the head. And the head is a pointer to this node. So if you have no nodes in your linked list, head will point to null, or in C++, null PTR. But the moment that you add a node to your linked list, your head is going to point to that first node. It's that simple. So you have a head that points to the first node. Each node has data in it, and also that node has a next pointer, and that pointer points to the next node in the linked list. Now, how can you tell how many items you have in a linked list? Well, you start at the head, and you simply count in a loop how many nodes you have. And we're going to actually code that. We're going to draw up the pseudocode for that, and then we're going to code it in future videos. But that's how you do that. Now, let's say we want to add a node to this linked list. Right now we have one data. I'll say data, I don't know, let's just say 1. So that's our first node. So data 1. And right now we only have one node in the linked list, which has data and next in it, and it points to null PTR. How do we add another node to that linked list? Well, what we do, which is actually pretty simple, what we do is and I'm going to go ahead and erase null PTR. Actually, let's not do that. Let's leave null PTR there. And then what we do is that we're going to create another node. And it doesn't matter where this node is located in memory because we're using pointers. It'll have a next. It'll have data in it. And let's call this data 2. And this next is going to point to a null. So how do we connect this node to say that our first data node is then going to point to our second data node? That gives you something like a vector or something like an array. Well, how do we do that? Well, it's actually pretty simple. Once you create the new node, then what you do is you replace the next from this first node. You replace it with a pointer that points to the second node. And if you notice, I created the next. When I created the second node, I immediately put the next equal to null or null PTR in C++. And so there you do. There you go. There you have our first node, and then you've got our second node. So how would we actually navigate this linked list? Well, what we would do in our program is that we would start at the head. So we would start there. That would point us to our first node. We would do whatever we need to do to the data, if that's what we need to do, in that node. And then to go to the next node, we would take a look at the next of that current node, and then we would get access to this node. So we're navigating through the linked list just like you would with an array, except with an array you would use a counter and an index. Now, how do we know that we're at the end of a linked list? Well, we know that we're at the end of a linked list when next has a value of null. And that's how you do it. There's no counter. Well, you can have a counter if you want to keep track of how many items there are in a linked list. But in this case, next will equal null. How do we know we're at the first node of a linked list? Well, we know we're at the first node of a linked list when head is equal to the pointer or the same address as our first node. That's how we know we're at the first node of a linked list. How do we know we're not at the first node or we're not at the last node? Well, that's a little bit more difficult. We know, so let's go ahead and create another node here. So I'm going to go ahead and create my next node. Excuse the squiggly lines. And there's our next pointer, and that's going to point to null. And then we've got data 3. And then what do? We navigate to the end of the linked list where next is equal to null. And then what we do is we replace that value null in that next pointer. We replace it with a pointer that points to our new node. That's how you append things to the end of the linked list. And let's say you're navigating through this linked list and you know, we started at head, so I got the first pointer to our first node, which is this one right here. We get the data in there. Let's say we're totaling up, I don't know, some number in the entire linked list. So we get the data, we then go to next. Next then takes us to this node. And we do what we need to do with that data. But how do you know where you are in the linked list? Well, you can keep a counter because you really can't access the nodes as like you can an array. But you keep a counter. But if you really want to know where you are at the end, is the pointer that points to this node the same as the head? Nope, it's not. So we're not at the first node. But how do we know that we're not at the last node? Well, we know we're not at the last node because next will not be null. So we know we're somewhere in between the linked list. And that can actually be very useful as you're processing your linked list. Now, at the very beginning, I avoided saying why are linked lists useful, why are they important? Well, this drawing kind of tells you one of those reasons. And one of the reasons is because the data can be located, this node can be located in this part of memory, this node can be located here, this node can be located here, and all of the memory in between can be used by some other piece of data or pieces of data. Now, why is that so important? Well, if you remember, if you know C and C++, an array is basically a long contiguous memory area. And let's say we're going to be creating an array of integers. Let's say they're 4 bytes in size. So you've got integer 1, integer 2, integer 3, integer 4, integer 5, let's say integer 6 and 7. And the indexes for each of these in the array starts at 0 and it moves forward. So this is an array of 7 integers, and each one is 4 bytes. This is how an array is actually implemented in the programming language. Now, how do we go to the third, or I should say the fourth? How do we get to that integer, the fourth one? Well, what we do is we get the address, the starting address of the array. We take the index times the size of each item in the array. We add that to the address, and then we get the address of the beginning of that item number 4, index number 3. So I believe that is the equation. Very, very simple equation. So arrays are very fast because it allows us to mathematically, or arithmetically I should say, get to any item in the array that we want very, very quickly. But to be able to do that, you've got to have every single piece of data must be contiguous. In other words, it must start at the beginning and end at the end, and there can't be any in-between data. It's not allowed in an array. So arrays are limited because the data must be located inside. The data must be located all in one place, basically, and so that mathematical equation of address or beginning of address. And by the way, the beginning of the address is the address of the first item. So that's the ADDR. So by having that, you can say address plus the index times the size of each item. So if let's say the address here is 0. Let's say the address of our array starts at 0. So the address of our first item would start at, what would that be, 4? The address of the next one would be 8. The address of the next one would be 12. And the address of this one would be 16, and so forth. So let's take the address of 0 plus, we're looking for the third item, or we're looking for index 3 times 4. That's equal to 12. Boom. The array at position 3, index 3, it's actually the fourth item, is the address 4. So you do that. You can do that very easily with arrays, but you can't do it with linked lists. But what if you have a computer system that doesn't have a lot of contiguous memory, and you need to store a lot of data in some type of a data structure, and you can't store it in an array? What can you use? Linked lists. You can use a linked list to do that. Okay, one other thing I want to talk about with linked lists is that there's a thing called, that's a singly linked list. So a singly linked list is a linked list where every node has the data and has a next pointer. And that's a singly, I don't even know that's how you spell it, singly linked list. Now these linked lists are really great for moving forward in the data structure. You start at the beginning, and you can move forward. Starting at the beginning, you can move forward through the data structure. However, there are some limitations to that. It's very difficult to go backwards. It can be very, very CPU intensive, very, very algorithmic intensive, a lot of loops, a lot of if statements. So there's another linked list called a doubly linked list, and a doubly linked list kind of looks like this, where you have a previous pointer, you have a next pointer, and then you have your data in between. And it doesn't really matter where the data, the next or the previous pointers, are located in the C++ class or the C data structure. But this is a singly linked list, and if this is, and you have a head just like you do, or this is a doubly linked list, I'm sorry. You have a head just like you do in the singly linked list, and the head always points to the first, but you've got another pointer called previous. And in this case, if previous is null, that means that that is the first node in the linked list, and this will point to yet another node as you add them to your linked list, where you've got previous, you've got next, and then you've got your data, and then here's the key, previous will point to the one behind it. So what's really nice about a doubly linked list is there's a little bit more processing that has to go in when you're actually creating the linked list, you're actually adding nodes. But what's really neat is this little previous pointer. It will tell you what the previous node is. So I can start anywhere in my linked list, and I can go backward, my doubly linked list, and I can go backwards and forwards. And again, this is called a doubly linked list. And I really should have put linked in here. So two different types of linked lists. One is a singly linked list and one is a doubly linked list. So, and we're going to be talking about in future videos, we're going to be talking about actually coding both of these linked list data structures. All right, so that's an introduction to linked lists. There's many ways you can code linked lists. You can use just about any language that supports pointers. And we're going to start off with C and C++. And what we're going to do in the next video is we're going to create the actual data structure that allows you to create the node both in C and in C++ to implement your linked list CNN.